everybody, my name is Mason Duhan, and today I will be teaching about simulating a mixing chamber in ANSYS Fluent. ANSYS Fluent is a computer program that uses CFD or computational fluid dynamics. Computational fluid dynamics can be done through a variety of computer programs, and it provides an inexpensive way to prototype different designs. This is used across every industry, or it can be used across every industry, whether it be aerospace, power plants, biomechanics, oceanic exploration. It's as only limited as your imagination. But today, since I'm a mechanical engineer, I will be teaching about using a mixing chamber. I will be creating a mixing chamber in 3 dimensions with 2 inlets, one cold and one hot, and 1 outlet. And since I'm to be able to teach this, I chose to do it with primarily primitives since it's an easier design and it's an easier way to show a lot of the capabilities of ANSYS Fluent. So here we have the setup after you open the ANSYS workbench. To pull up this small window, we simply click Fluid Flow Fluent, and take note of the Refresh Project and Update Project buttons. We will have to use those through each individual step, both geometry, mesh, and eventually setup. As you can see, the geometry is set to 3D, and this will cause our meshing to also be set to 3D. And take note of the setup. For precision, we're using double precision and 4 processors. This will make sure that we have a decent amount of accuracy while also not compromising the speed at which we're calculating. So this is the geometry window. Once you open up the geometry window, it will be blank. As you can see, I've filled mine with the finished problem. I did this particular problem by creating these cylinders and boxes. I built the entire outside of the body first using create primitives, and I selected cylinder 3 times and a box once. However, whenever you create a cylinder, it creates a solid rod, essentially, with no openings on either side. So to create our openings, I had to sketch the circles that I'd want where the opening is, and then extrude, which is up in the create, extrude, and it will open up this particular window. I selected the sketch, changed my operation to cut material, and just made sure that it was cutting deep enough into the cylinder to where the cylinder would end at the mixing chamber and not just go all the way through everything. I didn't want it to come out the back side to where we have a hole here for no reason, as could be imagined. I did the same thing for the cold inlet and for the hot inlet as well. Then I went on to naming the parts, naming my selections, naming the inlets and the outlet. I did this by selecting the top faces of them, right clicking and coming down to name selection. And then from there I went back to the workbench and opened up the meshing. Now the meshing started with simply selecting these 3 edges, the inside edges of all 3 of these parts. As you can see, I got both inlets and the outlet all selected and chose to divide them chose to use a number of divisions method for the edge sizing. The edge sizing, which is given to us from going up here to mesh, sizing, and I chose 45 divisions, behavior hard, no bias, and the rest was left at standard. I then went on to the mesh and created this fine mesh. It is important to have a finer mesh rather than a more spread out mesh because it allows for better accuracy when running your simulations and things of that nature. So I chose 0.1 meters as an element size. This was one of the smaller element sizes that I could pick. I remember trying to run 0.05 meter mesh sizing, and the computer essentially took 30 minutes and just told me it wasn't possible. Another way we could do this, or another way we could make this mesh better, would be by running a refinement process, but I'm happy with how this turned out, so we will then move on to the setup portion. And of course we have to refresh and update the project first. So this is the setup. Once it opens up with our double precision and 4 processors, we have solver pressure based, absolute velocity formulation, and time we'll set to transient. Since we're using a hot and cold inlet, we want to make sure our energy equation is on, as it is. And then we want to use a viscous standard K epsilon model. And if you're following along on your own program, these are the constants I used. Standard K epsilon model, standard wall functions, and so on. Moving forward, I chose the material as air, it is standard air, and then boundary conditions are set for the inlet, the cold inlet to be more precise. I set to 285 degrees Kelvin, and the velocity magnitude is 0.75 meters per second. And for the hot inlet, I chose to set the velocity a little slower at 0.5 meters per second and 875 degrees Kelvin. Using these boundary conditions, I then moved forward and generated a contour of temperature gradients, which I will show you at the end of this video. We used this to generate an animation, which is done through calculation activities, but seeing as how my computer is currently not allowing me to do so, we will simply acknowledge that. So as I said before, I used a hybrid initialization that will ensure that it takes into account everything we need. And to run the calculation, I set it to 500 time steps at 1 second per time step and 20 iterations per time step. Click to calculate, and it takes approximately 30 to 45 minutes to calculate and calculate the animations as well. From there, you can simply go to animations, playback. You'll have your contours here that you can then click, set it to the frames, and then you can set it to write the frames and set them into an animation. The animation, as I stated earlier, will look something a bit like this. Now it is important to note the swirls, and it is also important to know that once you begin to write the animation, you cannot move the camera angle. So it's important to have a good camera angle from the start. Otherwise, you end up with an animation where you can't properly see the outlets. However, for the intended purpose of this project, we will stick with this one. As you can see, let me rewind slightly. As you can see, the temperature of the hot comes in red and the temperature of the cold comes in blue, and it creates this wonderful little swirl pattern going on here. And that is all for this lesson. Thank you all for watching, and if you have any comments, please comment.